what we're gonna do, or what you're gonna do with your partner, or if your partner's not here, you're gonna kind of do it by yourself.
I'm Jeff's partner.
Well, everyone loves Jeff. Okay, so here's what you're gonna do. You are going to take this graph, which is the red graph, and you're gonna accomplish A, B, C, D. A says you're gonna use a blue color, and then you're gonna translate that red graph to the right 2 units. Sorry about the graph, the way it looks. 2 units actually means like if you were at 1, you would go to 3. If you were at 2, you would go to 4. Okay? Because the way my graph is drawn, there's too many little squares. That's not actually 1 unit. So like 2 goes to 4, that's 2 units, like 2 integer. Yeah. So anyways, you're going to draw the same shape with a blue color by moving the red graph to the right 2 units. And so on. And then you're going to do A, B, C, D only. And then check with your partner and see if you guys have the same graph. So using blue color, we're going to move it to the right 2 units. So that means, you guys are pretty smart. So you've noticed that pretty much we're moving all the vertex or the corner points and moving them and then kind of connecting the dots later. So that's good. Moving to the right 2 units, looks like that. Next, using the green color, we're going to move the graph down 2 units from the red. So that looks like this. Okay, still pretty easy. Next, using the purple color, I don't have purple on my graph, so I'm going to use black. So this is going to reflect over, which looks like that. The last thing is compress vertically by 1/2. How does that work? Divide all the points. Be more specific. What points? Every number. Huh? So X and Y? Okay. What were there other thoughts from other people?
Like you
Dilated? In a way, yeah, you're kind of dilated like geometry, but specifically, what did you do? Shorten which one? Did you shorten everything? Because the direction says vertical compress. Yes, you shorten the Y. Okay, so you're going to take the Y values and you're going to shorten it by 1/2. So basically, if it was 4, now it's going to be 2. If it was 1, now it's going to be 1/2. So you're taking all the vertical. The X direction doesn't change because we're only doing this vertically. So that means, sorry, I don't have orange on here. So this is going to be half the size, like that. So that would be the orange. Sorry, it's yellow on mine. But that would be the orange. You're basically compressing by 1/2, so you're making it half as short. Okay? All right, now what we're going to do is we're going to look at this whole thing in a table format. So what that means is I took the 4 points that were on the red. So I took the 4 points that were on the red graph. That is f of x. Remember, f of x is kind of like the function. So we have 4 points, 2, 2, 4, 4, 8, 4, and 10, 0. And I'm going to construct a table. So I'm just going to kind of write it all down first. So the first thing is we're going to set up a table for moving right 2. And then we have a table for moving down 2. And then we have reflect x-axis. And then the last one was vertical compress 1/2. And then we're going to look at how this all look like when we're actually moving the function f of x. I'm going to start with a down 2 first and on, and then come back to right 2 because right 2 is the trickier one. Okay, so let's look at our green graph, down 2. So if you look at the original graph, let's take, for example, this point. This point was 2, 2. When I moved it down, what did the coordinate become? 2, 0. So what exactly did I do to get to 2, 0? Yes, perfect. Subtract the y by 2. Subtract the y by 2. Now let's look at our function. Subtract the y by 2 means take f of x and then minus 2. Because remember, f of x means y. So we're taking the y and then we're taking that value and then subtracting 2. Therefore, we can predict how this graph is going to look like. Moving down 2 means we're taking all the y values and we're subtracting 2. So that's going to be 2, 0, 4, 2, 8, 2, and then 10, negative 2. And then you can double check to see if your points actually line up. They should. The next thing we're going to do is look at reflect x-axis. So how does that actually look like when we are talking about functions? So we're going to take, sorry, did you guys finish copying? Okay, so we're going to look at that same point again. 2, 2. So when we reflect it over, it's now on the bottom. What is the coordinate now? 2, negative 2. So then what exactly did I do to this coordinate to get there? Subtracted 4, put a negative on top. So basically when you flip over, you take all the y values and you made them negative, and that's kind of what happened to the graph. Therefore, we're putting a negative on y, so that is a negative on f of x. Because remember, f of x means y. So this becomes 2, negative 2, 4, negative 4, 8, negative 4, and then 10, 0 stays 10, 0 because you can't put negative on 0. Okay, so reflect x-axis means you're actually going to flip over x-axis, meaning the y's are moving. Okay, next, vertical compressed by 1/2. Vertical compressed by 1/2. We said we are shrinking the height by 1/2. So what do you think is going to happen? Yes, divide y by 2. So how would you write that with the f of x? Okay, f of x over 2 or 1/2 times f of x. Okay, so we're taking all the y values from the red one and we're dividing by 2. So that is 2, 1, 4, 2, 8, 2, and then 10, 0 stays 10, 0 again. Last one, right 2. We're taking this point, we're moving it to the right 2. So what did you do? Add 2 to the x. However, this one's a little bit tricky because the way it's written, I'll show you why later, it's actually going to be subtract 2. We are still moving right 2, but when you write it, it's actually minus 2. It's a little bit weird, so you kind of have to remember that this one's just weird. So the points are actually going to move right 2, so it's going to be 4, 2, adding 2 to x. So 4, 2, 6, 4. Oh, sorry, 6, 4. 10, 4. 12, 0. Okay, so in function notation, this is kind of how we're going to present it. So the big idea is this whole year, this is pretty much what we're going to do. Matt, you don't even know what it is yet. I have to show you a chart. We're doing the squiggly lines.
We've done the first 4.
Yeah, we've done those.
Good. So now we just have to learn these. Okay, so basically there are 12 basic parent functions. I mean, there are more, but we're going to learn 12. And the way this book is set up is every chapter is one parent function. There are 14 chapters, so some of them are a little bit overlapping. So we learned the parent function. Parent function means the basic functions. This is kind of like the basic of it. And what we're going to do is we're going to move them around like these. We're going to move them around. So every chapter you learn a few things. First, how the parent function looks like. Second, how do you move them around? How does it look like when you move them around in graph? Third, how do you solve equations that have to do with that particular parent function? And then you're prepared for pre-calc next year. Pre-calc next year, you are just going to learn the same thing but harder stuff. Okay, so that's that. We're going to learn all 12.
Wait, what's on step one? I noticed.
Oh, this one is called the greatest integer function. I will show you. Yeah, it's interesting. I guess they don't really teach it anymore. Our teacher taught us in 8th grade, but it was really strange. It was like
you learned
blur.
it in 8th grade?
Yeah, but I think they took it out of the curriculum now, so like nobody knows what it is anymore.
We don't need to learn it, right?
Yeah.
You just need to kind of know the idea, but I mean it's not like we don't use it too much, I think. Anyways, all right, let's come back. So, general functions. So this is how generally things are going to be transformed. So, okay. So before I show you what each thing does, let me show it to you on decimals. Okay, so let's review. K does what to the function?
It makes it taller.
Taller?
Up or down?
Up and down. Yes, moves the y. Moves up and down. What does H do?
Left and right.
Left and right? Okay, what does A do? Wider or narrower. So we call that stretch or compress. Stretch or compress. So what does that actually mean? All right, so for example, if I have like, think of it like a ball, like a rubber ball. When you stretch, you're going to pull it up. When you pull it up, naturally on the side, it's going to shrink it. So that's what happens when you stretch. You're pulling it up, so then naturally on the side, it will shrink in. Compress means you're going to push it down. When you push it down on the top, it's going to shrink, and then naturally on the side, it's going to stretch. So that's kind of how the function is going to look like. At the same time, it also has something to do with reflection. So it reflects x-axis. All right, so let's put that all together. Vertical translation means we are going up and down. So that is k. When k is greater than 0, we're going to go up. When k is less than 0, we're going to go down. Horizontal translation, that is the tricky one. So when you have an x minus h, you're actually going to go to the right. So when you see a minus, naturally you're going to think negative, but we're actually going to go to the right. And then so if you have x plus h, you're going to go to the left. That's a great question. The reason being, we're looking at the actual h value. So the actual h value, right, is positive, and in this one, it was a double negative. So it was a x minus h, so then we're actually going to the left. So it's a little bit tricky. Yeah, sorry. So yeah, so everyone gets tricked by that every year. Okay, stretch and compress has to do with A. Now, we are not looking at the sign of A. We're looking at the actual value of A. So we're always going to put an absolute value on top of it. So if that number is bigger than 1, it's going to stretch. So bigger than 1 means bigger than the original, right? 1 means you're just multiplying by something that gets itself back. So it has, if you want to stretch it, it has to be bigger than itself. And if you want to compress it, that means that number has to be between 0 and 1. So that's going to be compressed. Reflection, we only talked about one, but there are actually two reflections. One is over the x-axis. The other one is over the y-axis. Over the x-axis, we know that we're going to flip over the using the y value, so that's negative f of x. Flipping over the y-axis, we're going to swing over the y-axis, which means x is going to move. So that's going to be f of negative x. So we put a negative on x. Alrighty, we are going to do some quick checks. Alright, so you want to figure out how to move f of x into g of x. So f of x is my original function. I did something to it to become g of x. So this plus 6. This plus 6 is, you have a question? Okay. Plus 6 does what? So the question is that A, H, or K? K. It is K. How do you know? It is at the end, correct. So basically, this is the function. Whatever that function is, we are going to change it throughout the whole year based on which one I give you. But that f of x is just going to be the function. K is the number that you add on the outside. Okay, so if you look at this, the 6 is on the outside. Therefore, it is K. Now, what does K do? Up and down, up and down. So then this is plus 6, so it's going to be up. Yeah, so up by 6. So you're actually going to move it up 6 units. Okay, let's look at another one. Number 2, 0.25 f of x. Yes, compress. So compress, because that absolute value of that number represents a, is less than 1 or between 0 and 1, so it's compressed by 0.25. All right, number 3. This one's a little tricky. We have 2 things going on. Let's talk about that plus 1. What is that plus 1? Is that A, H, or K? H. It is H. Now, which direction are we going to move? Left or right? Very good. It's the opposite. So we're going to move left 1. And then that minus 2 represents A or K? K. Very good. K. So which direction? Down. Yes, down 2. Okay, last one. I think you guys can do this. Try it. What are the transformations? All right, let's see. Isaiah, tell me one transformation.
Down 1.
Oh, no, not down 1.
Oh, sorry.
Up 1,
Up
yes.
one.
And then, Karis, the other one?
Stretch by 2.
Yes, stretch by 2. All right, in this chapter, we're going to visit some parent function, but not all of them. We're going to start with the basic. First is y equals x. That is a straight line. The second one is y equals x squared. That is what we call a parabola. All right, first, let's talk about y equals x. That is just a straight line. You should know how to graph that. So go ahead and graph it on here. If you really don't remember it, you can put in your table. So, put in some x values, put in some y, figure out the y values, and then graph it. All right, y equals x is just the diagonal straight line. So it looks like that. Everyone still remembers how to graph this, right? Okay, next, parabola. You may not know how parabola looks like. Anytime you don't know how a graph looks like, you always put in your xy table. So you always want to put in some negative values, definitely put 0, and then some positive values. So usually I start with -2, and then I go up to 2. Okay, so what the table does is I am going to put in the x values into x, and then I'm going to try to figure out what y is. So when x is -2, what is y? 4. Very good. Please don't put -4. We're squaring the whole thing. That means we put that whole thing in a square. Okay, so that's positive 4. All right, and then we're going to get 1 here, 0 here, 1 and 4. So now we have these coordinates we can plot. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. When you get to that shape, please don't connect them with straight lines. They are actually curvy. So this is a curved line, which is the parabola. So far, just remember these 2 parent functions. So we're going to learn a lot of them. This chapter is mostly the line. You're introduced to a parabola, but not much. Next chapter is all lines and absolute value, which is the v. Chapter 4 is all of this parabola, and chapter 5 is all of this weird shape and then weirder shape, and then later on we'll do the other ones. Okay, so Let's do the first one. Given the parent function f of x equals x squared, write an equation for a transformation of translation left 3 units. Left 3 units. Left 3 is that A, H, or K?
Yeah, minus the H.
Oh, there are only 3 letters. H. H. Okay, we're moving left. Is that going to be plus 3 or minus 3? Plus. Oh, good. Very nice. Now we need to figure out how to actually put that in our equation. Now they tell us the parent function is x squared. We know that we're going to do an x plus 3 because we're going to the left. Because the parent function is a square, we're going to take this whole thing and square it. And remember, h is inside the function, so it's inside the x squared. So this is y equal to x plus 3 squared. That's moving to the left 3. Okay, next. Given the parent function x, write the equation for a transformation of vertical stretch 2 followed by translation down 5 units. Okay, try that. Your parent function is x. All right, let's see. Brooklyn, what'd you write?
Y equals to x.
Yes, very good. The last thing we're going to do is, this one's a little bit harder. You're going to change from f of x to g of x. And the question is, how did you do that? So somehow you moved from here to here. The question is, what transformation will you have to do in order to get from x over 2 to negative 2x plus 4? I'm going to give you a few seconds to think about it. What transformation do you have to do? Meaning, what do you have to multiply? What do you have to add and subtract in order to get from f to g? Let's think. First, we gotta change from x over 2 to at least a negative 2x, right? So what do I have to multiply to get from x over 2 to negative 2x?
Negative 4.
Good, negative 4. So in order to get from x over 2 to negative 2x, I need to multiply by negative 4. Next, I have that plus 4. So what do I have to do to get to that plus 4? Yeah, plus 4. Okay, now if you kind of think about it, x over 2 is f of x, so this is really kind of the same idea as this. So the question is, how do I write those transformations? What's the transformation that happened? Let's go down the line. Okay, Jackson, give me one. The transformation of f of x. What are these things around it? What are they doing to f of x? Give me one. You have a few choices. Negative 4 and then plus 4. Okay, tell me what they actually do to the function. No, don't remember. Okay, all right. Lynn, give me one. Yes, this is a common problem. Huh? What did you say? Reflect by? No. Okay, so let's talk about it.
Stretch by negative 4.
No, Nick.
Compress by negative 4.
No, none of them are correct.
You
Up by
reflect
4?
the add 4. You go up 4.
Okay, a 4 is definitely there. A 4. The negative 4 in the front, this is where a lot of people have problems. So none of the answers I heard were correct. Do you guys know why?
Why?
Because stretch and compress has to do with absolute value. Okay, yes, so stretch by 4. So remember, a in this case is negative 4, but we only care about the absolute value, so that is 4. So we would say stretch by 4, not negative 4. Then what does the negative do? Yes, reflect x-axis. So you want to just tell me what axis it reflects over. So there are actually 3 transformations. Please don't lump the negative and the 4 together as one big transformation. That is not correct. Those are 2 separate transformations. Okay, and a lot of people will make this mistake. They see the negative 4, they said less than 0, so compress. No, it's not compressing. It's actually stretching in the opposite direction. Okay? Okay, we have a few minutes. Let's look at this thing. We're going to fill it out really quickly.